You know, in this age of AI, there's a common fear, especially among engineers, the fear of being replaced. But what if that's just the wrong way to think about it? Today, we're going to break down a playbook that frames AI not as a replacement, but as a powerful force multiplier for engineering expertise. Let's get into it. So let's start with the question at the heart of it all for any modern industrial leader. I mean, your plants, your facilities, they are just swimming in data, right? But are your engineers, the people who need it the most, actually able to turn that flood of information into real, timely intelligence? This paradox, being data-rich but insight-poor, well, that's the dilemma we're talking about.
And to really get why this is such a game changer, we first have to understand the depth of the problem. So let's step into the shoes of a process engineer for a minute and see the daily grind that makes AI not just a nice-to-have, but an absolute necessity.
When you boil it all down, a process engineer's day is spent trying to answer two fundamental questions, usually under a ton of pressure. Is this little fluctuation in temperature normal? And, hey, has this specific alarm sequence ever happened before? And if so, what do we do about it? Now, with millions of data points, trying to answer that manually, it's like searching for a needle in a digital haystack. It's almost impossible.
Yeah, this really captures that intense pressure cooker environment. Engineers are constantly jumping from one task to another, putting out fires, and spending hours, hours, just wrangling data by hand. All of this creates this massive cognitive load that just grinds their most valuable asset, their incredible analytical mind, to a halt.
So, how do we break this cycle? Well, it's not about replacing the engineer, not at all. It's about completely reframing the tools they use. Let's take a look at how AI can act as the ultimate power-up for their irreplaceable knowledge and experience.
And this right here is the key concept. A force multiplier doesn't change the person, it just massively amplifies their effect. You know, think about it like giving a master woodworker a new set of power tools. The skill is still all theirs, but their output, their impact, it just goes through the roof. That is exactly how we should be thinking about AI for our engineers.
Man, this quote just gets to the heart of the whole shift. AI can handle the boring, tedious part, the what. It can sift through all that data and flag an anomaly in seconds. And that frees up the engineer to focus on what we humans do best, investigating the why and exploring those big, strategic, what-if scenarios that drive real innovation.
Okay, so theory is one thing, but let's get practical. How does this whole force multiplier idea actually play out in the real world? Let's look at some high-impact applications that directly tackle an engineer's daily challenges.
A successful transformation isn't some giant leap of faith. It's a structured journey. And this crawl, walk, run approach is perfect because it builds skills and confidence one step at a time. You start with some high-value predictions, then you move to actively optimizing your process, and finally, you build towards this incredible, holistic model of your entire operation. Let's see what that looks like.
So in the crawl phase, you start with something like predictive maintenance. Instead of waiting for a critical pump to fail, AI tells you it's going to fail before it happens. And the result? Well, companies like Siemens have seen a 25% reduction in unplanned downtime. That's a massive, tangible win right out of the gate.
Okay, once you're crawling, it's time to walk. This is where AI moves from just predicting problems to actively optimizing your process. By analyzing thousands of variables, it can suggest tiny tweaks to the settings to minimize resource use. And this can lead to savings of up to 20% on things like energy and raw materials. That's a direct impact on your bottom line.
And then you get to the run phase. This is the ultimate goal, really, the digital twin. Imagine a living, breathing, virtual replica of your entire plant. This means instead of doing risky tests on your actual equipment, you can run countless what-if scenarios in a completely safe virtual environment. You can find the absolute best outcome before you ever change a single real-world setting. Now, this all sounds fantastic, but how do you actually get your team there? I mean, you can't just hand them a new piece of software and expect magic to happen. It takes a real blueprint, a plan for building this new capability from the ground up. And remember, this is a journey, not a weekend workshop. This 18-month timeline is designed to build skills progressively. It starts with foundational fluency, just getting comfortable with the tools and the data. Then it moves to applied capability, where they're building real models. And finally, it all culminates in strategic mastery, where they can lead and deploy these AI solutions on their own. And the engine that drives this whole program is project-based learning. Engineers learn by doing, by solving actual problems. So in phase 1, they might automate a really tedious data task. In phase 2, they're building a real predictive model to solve a plant problem.
And by phase 3, they're deploying that model in a pilot program and even mentoring the next group. See? Every single step delivers real, tangible value. Okay, so you've made the investment in training and technology. Now for the crucial last step. How do you prove to leadership that it was all worth it? You absolutely need a structured way to measure success and show a clear return on that investment.
And this is where this dual framework is just so smart. On one side, you've got your program KPIs, which basically ask, are we learning? These are your leading indicators. Are people getting certified? Are projects getting completed? Then on the other side, you have your business KPIs, asking, are we winning? This lets you draw a direct, credible line from the training investment straight to the business results.
And here's what that looks like in action. This isn't just a feel-good story. It's hard data. A team developed a predictive quality model, and look at this. The product defect rate dropped from 3.5% all the way down to 1.2%. You can take a chart like this into any boardroom and instantly show the massive, quantifiable impact of empowering your engineers with AI. So ultimately, this transformation isn't about finding new expertise. It's about unlocking the incredible potential that's already sitting in your building. Your engineers have decades of irreplaceable knowledge about your processes. The only question left is, are you ready to give them the tools to multiply their force and shape the future of your operations?